Great, yeah. Good morning, everyone. My name is Dr. Rita Mirza. I'm a neurogeneticist, so I'm trained in genetics, molecular genetics, and I see kids with neurological problems in my clinic, and we're from Seattle. I'm from Seattle Children's Hospital. It's nice to see you guys.
Hi, my name is Hugh Xia. I'm from University of Rochester. I'm a researcher in the lab.
Good morning, everyone. My name is Yuna Xing. I'm from UW Medicine, University of Wisconsin Medicine. I'm a structural biologist. We use the high-resolution structure, trying to understand, what might go wrong with the structure of the protein of your target or the conductor, as Wendy Chang told us. And look forward to talking to you more.
And I should have introduced myself before, but I'm Wendy Chung. I'm a medical geneticist at Columbia.
My name is Rich Huncannon. I'm the chair of biochemistry and molecular biology in the College of Medicine, University of South Alabama.
Good morning, everybody. I'm Veerle Janssens. I'm a PP2A biochemist from the University of Leuven in Belgium.
Good morning, everybody. I'm the vice chair of neuroscience and pharmacology at the University of Iowa. We work on making mouse models of Jordan syndrome.
Hi, I'm Brian Wadzinski at Vanderbilt University in Nashville, Tennessee. I work in the Department of Pharmacology.
Perfect. All right. Let's go ahead and get started with those questions. If you have one you would like to have answered, please raise your hand. Brittany, you're in the back. Let's start with you. We do have some questions from our virtual team.
Okay. So something that we have coming up online as well as on our Facebook group is, sorry, can you not hear me?
There you go.
Okay. Something that we've been discussing in our Facebook group, and I'm also getting in a question online, are about genital changes that can occur in children. This is specifically a 2R5D individual. She says her son has undescended testicles and is about to have an operation. He's now 3.5. Is there a chance this won't fix itself? And are you seeing this in other areas in the population?
And anyone who would like to talk to that?
I'm going to try and repeat the question because I'm not sure I got it.
Okay.
I heard undescended testicles in there, and then what was the other part? Are we seeing undescended testicles and what to do about it, or was it something else?
Correct. It seems like they're going to have an operation. She's wondering if this has a chance of fixing itself and what else is going on in the community if other people are experiencing this.
Okay, so again, I hope I got this, but if not, and Rita certainly chime in. So we do see an increased frequency of undescended testicles. For boys, we oftentimes will give them some time to come down and stay down. If they don't come down and stay down, though, we do a simple procedure, literally to tack them down within the scrotum. And the reason we do that is because if they stay up in the abdomen, there's an increased risk of cancer, and we don't want them to develop any sort of testicular cancer. But it's a very simple, usually one-day procedure if it needs to be done.
Thank you, Wendy.
Okay, question here in our group.
I had a question. Is there an update on the research, the trials, like where we stand with that?
Well, yeah, so at this stage, we are looking at the cellular level and at the animal level. So the idea is that when people have donated their blood, we've been able to make cells from those individuals that we can then study. And so what we're at, I'd say now, is looking at the signaling pathways. What is wrong? We're trying to figure out really what does R5 do in a biological setting, and then how do the variants alter that, and then how do the different variants alter in the same way. And so the idea is when we understand what to do, then hopefully we can come up with interventions for that. And so there are three paths. One is the genetic fix, and so that would be to go in and say, okay, this is the change that occurs in the DNA, and can we then fix that? And you may have heard of the technology called CRISPR, and that has been used. We can actually go in and fix several of the variants in the cells, in some of the cells that patients have been given or have provided. And so that's a big advance, but there's a long way to go because when we do this in the cell, we take thousands of cells and we can fix, at first we could only fix 1 in 300. Now we can fix about 90% in a dish, but we have to get to the point where you can actually do that in an animal first and then a human. And so the real challenge is getting this fixed in all of the cells in the body. And then the other approaches are, there's one called antisense oligonucleotides. And so the idea there is that the gene, you can think of this as the code. The gene is transcribed into mRNA. So this is the messenger, if you will. And then that is converted into the protein, which is the worker that does the function. And so you can attack this at the mRNA level. So you can make an antisense oligo that basically intercepts the variant protein production. And so that's a very challenging thing because, again, we're changing just one base, and then it's going to have delivery. And then the third option is looking at the signaling pathways. We think that RFID is kind of an orchestra leader. And so we're trying to figure out all these different pathways that are affected, and then what are the most important. And there, you have different paths. So you can also think of it kind of like think of it as a highway system. And RFID might be driving a truck, and it's going down the highway, and if traffic is going smooth, that's fine. But all of a sudden, the variant says, well, I'm going to go the wrong way. And so it's going to drive backwards against traffic. So one idea is, can we stop them? Can we stop the truck from ever getting on the highway? Or can we divert the truck off the highway? So there's many different paths for developing what we call small molecules, and those would be drugs that you could take. And so at this point, we're trying to figure out what is wrong, and then can we stop this at a cellular level, and then after that, we'd take it to the animals, and then it would go to human trials. So we've made a lot of progress. We understand a lot more than we did just 5 years ago, but it's become a very complicated process. This is a master regulator protein, and we've got to figure out what it does. And from that last path, it's probably not going to be a single fix. We might be able to say, okay, we can divert it off to the right, or we can divert it to the left and get some of the symptoms. But yeah, we still have a ways before we'll get to a human clinical trial.
Okay, next question? Anyone here in the room? I think Kayla's coming to you right now.
Hello. Do you think there's going to be an age deficit? You know, will there come a time when they're too old to do any of your investigations as such? Or would it work better on young children? And do you think there's going to be an age gap at all?
Yeah,
You're going to have to hold your mic up.
Yeah.
Do you think there's going to be an age gap at all? Because the older they are, the less you can sort of change as such?
I still didn't get the question.
Is your question that you're asking, is there an age in which they will essentially age out of being able to be assisted?
Yeah.
Okay.
Say that one more time. Aging out of?
Aging out of being able to be assisted by any of the work that's being done.
She's asking if the treatment will be less effective as they get older.
Yeah.
I got it. Okay. So I'm so sorry. I'm going to rephrase the question, which is a very good question. So as children age, the question is, will a medication or whatever treatment always be effective or equally effective over time? Right? Did I get that? Okay. So the answer is we don't know. That's the honest answer. We think about ways of doing this experimentally in animal models. I think of it as flipping a switch in terms of being able to have a time when we can flip the switch and rescue genetically and see. That's just an animal, though. It's not necessarily a person, and so it doesn't always translate. I think the honest answer is we won't know until we do it. I think we do think about part of this as being about development and brain development. And with that, I do think there's a window in which the brain is developing in which this is maximally effective. But we also know, based on what this gene does, that it continues to be important in daily functioning. So I don't think it's going to be that it's not going to have any effect if we could do this even at an older age. But I appreciate the question, and I think we ask ourselves all the time this exact question, and we can make guesses, but the honest answer is we don't know.
Thank you.
Brittany, you have a question from our virtual group?
I do. I have several questions about seizures that kind of piggyback off each other. So first of all, it says that our child has had seizures and is currently on medicine, but we are unsure whether it's working. How long would you give it a chance to see a difference before you try something else?
I'm so sorry. I think I missed a part of the question, actually. So the child had seizures, and they're not sure if it's actually seizures or something else? Is that part of the question?
No, they are on a medication for their seizures for treatment. They're not seeing a difference. How long should they continue the medication before they try a new avenue?
Yeah, so that's a good question as well, because certainly, as Dr. Chung highlighted, a lot of kids have this issue. So it really depends. So neurologists can actually have different ways of doing this. But I would say that if the parents are not seeing any reduction in seizure frequency on a particular medication, absolutely to go talk to their doctor right away and not wait, too long to see about whether, a dosage adjustment needs to be made or switching to another medication might be needed. If they don't see any effect at all, that means probably that the medicine is not really doing what it needs to do. And the good news there is that there are so many anti-seizure medications right now, so the menu of seizure meds just keeps growing. And the newer generation seizure medications, anti-seizure medications, are really good. So these drugs keep getting better and better overall with less and less side effects. So I would say to talk to their doctor. I hope does that answer the question?
I think so. It might also be helpful to the family. Are we talking a matter of weeks for the medicine to take effect or longer?
Yeah, so that is an individualized decision because it depends on the seizure type and how many episodes are being seen a day. So just to give an example of like a way we think about it in clinic, if it's like the generalized shaking seizures, we usually don't try to sit on those too long. Certainly if there's multiple episodes a day, we would want to address that right away. If it's the milder type, as Wendy mentioned, where it's like spacing out and they're really hard to actually know how many are happening. So if they're that kind, sometimes we kind of have a longer time to figure out what's going on with those. And that's okay, but in general, if it's multiple episodes a day, certainly we would want to bring that up right away to the neurologist or the pediatrician who's taking care of the child. Does that, Brittany, answer most of the question, or?
I believe so.
Okay.
I have one more specific question, but I think it might be relevant to the group. One of the children that's having seizures for more than 30 minutes has been prescribed a strong medication called Stasolid, and they are concerned about using it because of its side effects. And they are wondering your opinion if they should give it a try.
So I wouldn't give a blanket advice to everybody because again, in terms of the side effects, it really varies from child to child. And every family is going to be different in terms of the perception of acceptable side effects that they're willing to live with and not acceptable side effects. So in general, what I'll do if we were in clinic, I would really have a conversation about what are those side effects that are concerning and take that and balance it against the type of seizures and how frequent they are and how bad they are. There is a balancing act, right? So you're not getting a perfect solution each time, but if the benefits outweigh the risks, I would say, I know this sounds a little bit like generic kind of advice, but it really comes down to what is that side effect that they're concerned about and really talk about it. This medication in particular is used quite a bit at our center, but we've seen kids come off of it sometimes because they're switched to another medication. So, it's really hard to give very specific advice. I don't know, Wendy, if you wanted to add anything to this, but...
No, as we're saying, because we don't know your child in this case, we don't want to try and prescribe or try and be their doctor. But in general, the general guidelines that we're giving are talk to your doctor who knows your child best.
Thank you.
Okay, questions over here? Of three of them, in fact.
Good morning, panel. It's a pleasure to be here. My name is Karina. I'm from Argentina, and I've heard in one Zoom meeting we had, I don't remember when, about a molecular medication. I know CRISP looks like complicated to achieve, but maybe I was wondering how close we are to this medication. I mean, to work out some effects of the PPP people, like seizures or speaking, or, I mean, if you can give us like, it's not like I want a date, but I mean, do we have to wait 3 years, 4 years, 5 years? I mean, are we close or not?
I mean, we don't have an answer for when this will happen. I mean, we're at the cellular level where we're looking at things. I mean, I think the fastest path would be is if we can find a drug. There's a signaling pathway that has many different members. And there are drugs that target those already that have been developed for other disorders, cancer treatments. And so the fastest path would be is if one of those compounds proved effective in cells and then in mice, then they've already been through the phase 1 clinical trials and could go faster. If we have to come up with something that is completely novel, you're talking many, many years.
Okay, thank you so much.
Maybe I can just, add a little bit, some other rare disease. I probably show in the poster today. And in that case, there's a TTR. They have 120 different disease variants. And after they found the first compound, they have to stabilize the protein behavior, and then take about 4 years or so to get an expedited FDA approval. So that's kind of like a fast track. What we have right now, by structural understanding, as Dr. Wendy Chang mentioned, is a conductor. Alpha-IVD is a conductor. And what it does, the two flexible two arms, and they keep, when it's needed, they keep it silent. They suppress the mouse, where the active site would take away the phosphate. And also their side, the recruit singers and the saxophone players, and down below, they're also silenced by the arm. And when it's activated, need to be. So the way to silence all the ID residues, our kids' mutation sites happen to be all on those anchor points of the arm in a silent form. So what we're hoping, maybe we can find, the chemicals anchor site. They can help to reverse, the effects of mutations, how they affect the movement of the arms. Hopefully, we can find that kind of compounds and might be beneficial for more kids, not just the one type of mutation.
Okay, there are a couple more. Kayla, there's...
Can I just ask
Yes.
Can I ask a follow-up? This is just an immediate follow-up on this, sorry. So when we were in San Francisco, can you hear me okay at the front?
Yes, you're good.
When we were in San Francisco 3 years ago now, I think it was, Jan Nolter was talking about the various pathways through to finding a cure, and said that you guys were working on the FDA approvals, sort of front-loading everything, doing all of that stuff alongside the clinical molecular work that was going on. Has there been something that has slowed things down? Obviously, we've had COVID, which is going to have impacted things, but has there been some discovery in this that makes it feel like that this is actually more complicated than you initially thought? Because I think that the impression that we got 3 years ago was that there was this sort of, we were on this really fast track and moving forward, that everything was running in parallel and it was looking great. And now it seems that we're sort of further back in the process and actually things are going slower than you originally anticipated. Is that the case?
So I'm not a biochemist, although my esteemed colleagues here are, but so I'll say that things are complicated, and I think we're increasingly appreciated how complicated they are. And I'm going to try and put this a little bit in perspective. So number one, we actually do have the protein structure right now. And I know that just sounds like not a big deal, but it's a huge deal in terms of understanding this and being able to, in an intelligent way, perhaps engineer a compound or a medication that instead of keeping the protein in a closed position, might kind of prop open the door to be able to keep it more active. I think I'm increasingly realizing from my colleagues, though, that it's not a matter of always being closed or always being opened, but getting it just right in terms of being opened long enough and at the right time and allowing the right things to be affected. So in other words, it's a very large orchestra, and I think we appreciate now that it's not just 10 members of the orchestra, it's maybe hundreds of members of the orchestra. And we have to figure out what are the most critical members of that orchestra for brain function. And so I think we're in parallel trying to figure that part of it out so that if we have to really push hard in a certain area, where do we push? Is it the woodwinds? Is it the brass? Is it the percussion? Is it everyone? We don't know. Yeah. So that's, I would say, one portion. On the other hand, I do want to say I think that area is really important. And some of my colleagues may or may not appreciate this, but a medication, a pill that you could take is just from an everyday quality of life, a really easy thing to be able to administer for our folks. So I think it's really important for us, even though that's hard to do, to prioritize that as an important therapeutic strategy. In parallel, and this is what we were saying, we haven't put all our bets on one strategy. We've actually been pursuing at least 3 strategies simultaneously. Admittedly, that's hard to do multiple things, but in part that's because some are near-term easier, and I think perhaps a bridge to a long-term one-and-done solution. The one and done with a gene therapy or a CRISPR or gene editing or all of those types of things, I personally think our group is not going to be the first one out of the gate. We're letting other people go ahead, work out the kinks, make sure it's safe, make sure it's effective. Then we'll hop on board that train as soon as it's ready. But we're going to let other people do the heavy lifting because it's expensive and it's potentially dangerous. And so in the meantime, I think we're looking for bridges until we get to that permanent one and done solution. So we mentioned these ASOs or oligonucleotides. We're also using other groups that are doing this ahead of us to tinker, to work out the kinks in those systems. And I'm personally not sure how well that's going to work. I do have some concerns in terms of can we get the conductor to balance things just right doing that strategy? And the way we have to administer that is not just a pill you take. It's a much more involved process. And so I think we're trying to be cautious in terms of the risk we would potentially put someone under. So I do think you've detected correctly that we're realizing it's more complicated than we may have thought in San Francisco. Within that, though, we're trying to simultaneously not put all our eggs in one basket so that if one strategy works in the short term, we've got something else in the longer term that will eventually be able to make quality of life as good as possible.
Carol,
Yeah,
go
I
ahead
just
here.
wanted to add a couple things here, and I think Wendy covered some of that. These guys are always worried about our hopes and expectations, so they downplay everything they tell us at the same time. So keep that in mind. But the 3 paths that were mentioned before, these are all still going. You will see from the UC Davis team, they'll have the poster about the CRISPR technology and what the testing they're doing there. The small molecule is also happening. The team is testing at a cell level. The hope is to find an FDA-approved drugs that will work for this application because that will be the fastest path forward. And there's real-time testing happening in the labs on multiple drugs to see how it acts on the cell level. And in the workshop yesterday, we're talking about which ones of these will be good to test on mice and see how that improves the mice level as well. And so, and then there's a lot that we still don't know. That is true. This is complex, and that's, I think, the word I heard a lot yesterday in our workshop. But at the same time, we do have a plan, and the team is moving full speed to do that testing. Some is more long-term, some is like some, high shots to the target. Is this going to get us there? So there's a lot happening to see, and we're basically waiting on a technological breakthrough right now that we're like, oh, that's what it is that will open doors forward. So I don't want anyone walking from this thinking that we're not where we were before. We are, and we continue to move forward. It's just there's a lot to do, and you all being here is helping exactly that, because there's a lot of learning that's going to come out from this conference that this team is going to use to move us forward. So we have faith that we'll get there. It's just a matter of, going through the process.
Carol, thank you. Couple more over here, one down in front. We know we have Niels in the back and another one over there. So let's go here first.
Hi, I'll try to go quickly. Our daughter is 6.5, has never had a seizure. I'm curious what the likelihood for children who've never experienced seizures or some of the other more complicated symptoms, if they will have the onset, coming years.
I think in part we don't know. As you saw from the distribution, most of our kiddos haven't made it through puberty and adolescence yet. If I had to give you a general, I'd say 50-50 in terms of things. The fact that she hasn't had anything yet, I think she's more likely to be in the 50% who won't during adolescence. But we still, as a community, have very small numbers of those who have made it through adolescence so far. So stay tuned, but keep an eye open, just pay attention.
Kayla to Tom, and then we'll head back over this way.
There's a quick follow-up question on that. So the question is, if there are no seizures, but there's abnormal EEG readings, what does that mean in the long run?
So I think that's part of why we got the EEGs here, is to understand with individuals who aren't having seizures, what does that EEG look like? I don't necessarily think an abnormal EEG is going to equal seizures in the future. So I want to reassure people of that.
Okay, Tom, to you.
I was just going to ask, reading the research, it seems like there's 3 subunits, I guess, to the phosphate you were just discussing. And in 2 of them, it only seems like there's 1 gene, but in the 3rd one, it says there's 15 genes. Does that mean like at some point there'll be, in this group, there would be like 17 different genes as part of this group?
Yeah, I get. So the phosphatase is what we call a holoenzyme. So there's a catalytic subunit, and that's what actually does the dephosphorylation. And then there's the A subunit that's kind of a scaffold, and that holds the catalytic subunit with the different B subunits. And so there are at least 18 different genes encoding the B subunits. And it's a little more complicated because there's actually 2 genes encoding 2 almost identical C subunits and 2 genes encoding almost identical A subunits. So when you start doing the combinatorial math, you actually end up with almost 100 different holoenzymes. And that's part of the complication that's emerged, because if you just put R5D in, that can actually form 4 holoenzymes. So yeah, the whole family is going to be a 2A family. But these individual holoenzymes probably have unique functions. So if you have a mutation in the C or the A, it could affect vastly different or similar, depending on what B subunit's in there.
Niels, up to you.
Yep, hi. So I had read about a case in the U.S. courts around the RARE Act. I don't know if you guys are familiar with that. It had to do with orphan drug exclusivity that ruled in favor of the pharmaceutical companies, which at least on the surface said that that was a bad thing for those of us that are looking for use of existing medication to solve other problems. Are you guys concerned about that? And if so, is there something we can do to support the legislative effort there?
Yeah.
Do you mean FDA-approved drug repurposing? So meaning that it's already FDA approved and tried. So we do, after we solve the structure, we try to dock the FDA-approved drug and try to test how they might affect the holoenzyme behavior. But we see some of the compounds can bind to the holoenzyme, but the efficacy is extremely, extremely low. I think below 300 micromolar. So it's not good enough. Otherwise, we would love to try those compounds. Does that answer your question?
Yeah.
Okay, I'm sorry.
Yeah, I mean, I think cost, of course, is a concern. And the real challenge here is that, you know, if it is something that is FDA approved, I mean, physicians can use things, I would call them off-label. So if it's approved, then and it's useful, it can be prescribed. For a new compound, the challenge here is actually finding it and developing it. And then, you know, it's always a challenge with the pharmaceutical companies for cost. But they do have cost associated with development and then production. So it's a challenging question.
And also to follow up on that, there's a lot of legislation going through the Every Life Foundation, and rare disease legislative advocates are doing a lot of work. I have an email that just came out yesterday, in fact, so I'll make sure that you see this so that it gives some information. It's talking about the orphan drug tax credit and reconciliation, the work that's being done behind the scenes as well. There's a number of legislative acts happening right now, Food and Drug Amendments Act of 2022. So let's talk, you can see this, and then we can get you connected with Every Life too, because many of the legislative advocates that are out there are working right now on all sorts of different legislation for the rare disease space, and they're constantly sending out emails. So I'll connect after this, don't let me forget. And anyone else who's interested too, we can help with that. Drew?
Yeah, so I was gonna that's where I was actually gonna go with what I was gonna say. So first I wanted to thank you guys so much for everything that you guys have done for all of us. And then I was kind of actually going to talk about what Christina was saying. Anyone that lives in the U.S., the Every Life Foundation actually has a rare disease conference, or on Capitol Hill they have a yearly meeting. And their big thing is that what we could probably do to help the researchers is they're trying to pass something called the STAT Act, which is speeding therapy access today. So it would help our kids a lot because one, it's going to increase funding for a lot of what they're doing. And two, it's going to try to streamline so that our kids don't have to wait so long if they get to a point where they can pass this. It's basically going to set up a center of excellence within the FDA, like they've already done that for cancer. So a lot of cancer drugs and stuff are developed a little faster because they have this center. So they're trying to do this with rare disease. It's just kind of stuck right now in the House and the Senate. So if you live in the US, the biggest thing you could probably do is reach out to your congresspeople and your elected officials to just get this passed, because I think that's what's gonna really help our kids, because there's a lot of money out there, they just have to streamline it. And it has a lot of bipartisan support, so hopefully we could get this passed. It's just sitting around right now. So
Yeah,
that's where I was going
it's
with
true, and there's a good way to connect all of you to rare disease legislative advocates. As a team, the JGA team attended their week-long symposium on Capitol Hill. We did it virtually, so any of you can attend that. And the nice part about that too is that not only do you get to hear what Every Life is doing in order to move all of this forward, and rare disease legislative advocates, but also you get a chance to sign up with the lawmakers that are in your area. So you can sign up with whomever they may be, meet with them, talk about the importance of this, try to get these bills moving forward. So if anyone's interested, we can help with that on our end, on how to register, how to get involved, and to find out all of that information, because it's very helpful. They give you very easy access to those who are right there in your community, and you talk to them one-on-one. So I think we met each individually with 4, 5, 6 different members of Congress on a regular basis. So just keep that in mind, that that's open to any of you. Yes, back over here. We're coming.
I just have a question about like the sample size that you're working with. Obviously, all these kids seems like are really heavy on the younger age. Is there anything being done, and is there anything that can be done to increase the number of individuals that are being watched and studied as they grow to answer some of these questions that are coming up? Otherwise, it seems like we have to wait 20, 30 years to really get a lot of these answers that are to the questions that are being asked.
Maybe we can take some of that, Christina, about our awareness and outreach efforts.
Yeah, and I think that's a huge part of it, and this is sort of where many of you come in as well, because in order for us to reach a broader community, we have to start speaking up about what we're doing. We're doing with our team, we're doing it on a regular basis, but this is where we tap into all of you. We've connected you in your binders. You have all of your medical information. It's a one-stop shop. We have the resource center on the website. Please look at that as well. Give the information to your medical providers, any and all of them. Let them see it. Make sure they know about it. Please send them our way if they have questions. We are happy to help with that. Tell your story. Share what we're doing. The more people that know what Jordan's Guardian Angels is and what Jordan's syndrome is, the more we can start to reach out to others who think, I don't know what's happening with my child. Why is this? What is it that's happening? So we're able to sort of bridge that gap on our end too, as a group, as a whole team. So that's part of it, is the outreach effort. The other part of it is working through all of the steps that this amazing team is doing.
I'll also point another part to this as well, is that there's a bias in the literature, and Dr. Chung highlighted this as well in her talk, is that we need to acknowledge and be aware of this bias, and I would like to emphasize it real quickly, just so you know, that there is always, with rare genetic disorders, if you will, there's always a bias towards the pediatric population, being identified first, because sadly, a lot of adults with genetic syndromes may have barriers towards getting a genetic diagnosis. And these barriers are multifactorial. Part of it is insurance policy, and coverage for genetic testing, the ability to see a geneticist and how soon they can be seen, and all sorts of other things. So I think there might be a lot of adults walking around with this syndrome, but they might not know about it, or their families don't know about it, and there can be barriers to that. So I think that those barriers we need to respect those individuals in the sense that, it might not be the easiest thing. We would like everybody to get a diagnosis, but it's not always possible. So I just want to highlight, the graph that Dr. Chung showed really highlights this phenomena, and it's not unique to Jordan syndrome. It's seen across a lot of others. So as much as awareness is a really big part of it as well, I think also improving access to genetic care in general across the lifespan is another part of it that a lot of groups are working on, and I think a lot of us respectively try to do that in our own settings as well.
Which leads us back again to legislation, because there is legislation out there for newborn screenings. Again, that's sitting, waiting, hoping to be moved forward on a broader scale. So there's a lot of work that can be done from all of us as well. Back in the back. Yes, go ahead.
I'm loud. It's not so much a question necessarily as a comment, but the data is, I see, based on, I think it was 82 individuals. I'm not quite sure the total numbers we've got now, but it looks like you've basically got about half of the people, and that therefore there are still a lot of people that need to sign up to Simon Searchlight. Is that right still?
That's right. So we have about double the number of people, I think, in our Facebook community, and about half of whom have signed up and given the data. I don't want to pressure anyone, because obviously it's a personal choice, but if there's something that the mechanics, you don't know what to do or where to go or anything else, feel free to see me. We also have part of the Searchlight team upstairs on the second floor, but we really make it easy.
Yeah, it just seems that please sign up, everybody, because it's our data that's going to get the results, and if the data isn't there, then there's only so much that these guys can work with. So there's 82 of us, and I'm sure that there are a lot more people who can sign up.
Also, to add to that, there's a parents committee for Simons, and I am a member. I represent all of you. My name is Lucy, Nice to meet you. You can friend me on Facebook. They are extremely helpful. It's super easy to join. They have different languages, so it's not difficult at all. They have videos explaining what you need to do to sign up. Please do it. If they cannot help our children right now, think about the other children in the future that the data that we give them are going to help. So it's not difficult. Please do it. If there's anything I can help with, ask me. If I don't know, I'll help you. We'll find a way, but they are amazing. Please join. And don't be afraid of sharing your data, your EEGs, your MRIs, whatever they ask you for. Please, that's the way.
Yeah, I'd like to add one more thing to that. So another thing, as we develop compounds to treat the children, one of the things that the FDA is going to want to do is they're going to want us to have some way of assessing, is your compound indeed making a difference? And so the data is also very important for that. We need a baseline. We need to say, this is how the children are. And then after they're given the drug, we need to be able to show that there's an improvement in that. So the data is also very important to establish that baseline.
Hi, I just wanted to piggyback on something that was said over here. My name's Michaela. My daughter Poppy is 13 years old. If any of you have younger children and you have questions, it's like Dr. Chung said, we are Dr. Moms, we are Dr. Dads. There are a couple of us in here with young adults, with teenagers. Find us on Facebook, ask us the question. If we can help you, we will. We're all a community, we're all in this together. We can only learn and grow from the experiences of our children. So I know I'm speaking for all of us here with the older children. We've been through what you're going through, and if we can help, then we will, okay?
Okay, to sit in the back.
Part of our awareness play has always been, or I thought it always was about, can you hear me? All right. Though we're a small community with 200 families, that the research that you're all doing can potentially impact a much broader audience outside of the rare disease community. Is that still true, and what do you see that looking like? Because as we as parents talk to others about the research and the funding, that's what generates a lot of excitement for folks that don't have kids with Jordan syndrome, is the potential broader impact that the research is going to have. And can you speak to that a little more?
So I'll bring up one point that I didn't emphasize, but for those of you who have been to the meetings or watch us online. So we did identify one person, initially it was one person that I had identified that passed away with Parkinsonism. And it was an unusual feature, we thought at the time, associated with Jordan syndrome, and we've since gone on to realize that it wasn't unique to him, that we've seen it also with other genetic variants and in other individuals. The good news is that it responds to the medications that we use for Parkinsonism. We haven't been seeing it in anyone younger than their 30s, so it's not something in our young little ones, but it is certainly something that we're watching for our older individuals. But again, I want to emphasize that recognizing it, there are medications to be used for this. We have been thinking about, to your point, how to leverage this in a way to be able to think about how we understand the brain and biology of the processes that are more generalizable for a larger community with Parkinson's, and be able to think about how to use that not just for Jordan syndrome, but to use it for other individuals as well, and to be able to get resources that will also help more people. So we still absolutely, collectively, the community here uses that information, and to some of the other points that were made, we try and think about how that entire complexity of phosphatases, which really is complex, but I do think there are a lot of synergies and things. So we really are trying to bring all of that to bear, all of the researchers, all of the expertise, plus all of the financial support by using all those strategies.
So if I can add to Dr. Chung here, this discovery, her discovery has sparked a new collaboration between my laboratory, who works on with the mice that we're using to model Jordan syndrome, and a collaborating group at UC Davis to actually use our mouse models to find signaling pathways that are related to both Parkinsonism as well as perhaps the intellectual disability, to see if perhaps there are parallels that can help us essentially treat both ultimately Parkinsonism, that of course to which a lot of money is funded, as well as these intellectual disabilities, to perhaps come up with a medication that can treat both.
Okay, next question. Down here in front.
Hi, my daughter is 25 years old, and she was diagnosed at 20, and she would have never been diagnosed as an adult, I don't believe. I was told by her practitioners that followed her, Children's Hospital of Philadelphia, that she needed to get in before she aged out to get the testing done, and she did, and then we found this after a whole gamut of years of other testing as well for various different chromosomes. But anyway, what I was wondering about was she does have tremor, and it does, I've heard Parkinsonian-like, and it is more significant as she's getting older. What is the connection? What are you finding as far as the connection to that?
To talk to me later. I do think
Okay.
I do think it's related. I think that's some of the early features that we're seeing, and I do think there are medications that could be helpful at deciding when to do that, but I do think that's part of the package that we're seeing.
Okay, very good, thank you.
Okay, we have more on this side of the room over here. Tim, okay, you have a mic, good.
Good morning. First, I'd like to say thank you to all of the research, the group that's been working so hard for many, many years. I know that a lot of people have flown from all over the world, literally, and I think one thing that might be helpful for the group is, maybe this isn't the setting right now, but before we leave this weekend, this conference, I think it'd be helpful for the group if you all were to get together and maybe provide a big picture overview update on where you're all at together, just to keep everybody updated in relation to where we currently stand with our goals. Just a current status for the group, I think, would be very helpful. Thank you.
Just one comment on that for Tim and others. So in your binders, there's the 2022 research update. It's in one of the sleeves. And if you read through that, it has all the latest and greatest happening with the research, where we're at with that, how does it, compare to where we're going. So do take the time and read through that. There'll be more questions after that, I'm sure, but at least it'll give you a dump of kind of current snapshot, and then we can expand on that from that. And then you'll get an opportunity to stop by each of the posters and learn more about the work that's being done, and then sit down with Dr. Chung, Dr. Mirza, and Dr. Jensen for one-on-one for additional questions on that as well.
Brittany, I know there's some virtual questions too, so let's do that, and we will get to the questions here in the room. Go ahead. You may have to be really loud.
For example, they have provided results for an MRI but have never had an EEG.
So it's very simple, and maybe what we'll do is distribute instructions on how to sign up at the end of the meeting, so everyone's got it in their inbox. But all they need really is a copy of their genetic test report so that we can make sure they're in the right club, and then after that, they can do everything online.
Okay, if you don't, oh, sorry, go ahead, Rita.
No, Brittany, I just wanted to add for the brain MRI, is it a brain MRI you mentioned that they had, but not an EEG?
That's my understanding.
So because we do have an arm of the study, which is really relevant directly for fundamentally understanding seizures, is that for any child who had a brain MRI scan, particularly if the report said that there was something there, we would like to actually receive the brain MRI, because we put that data with the Simons data as well. So our team here in Seattle collects brain MRI scans from children, literally the actual scan, and we can help sort through how to do that. Or the report, but the scan is actually getting the scan is even better, so that we are also looking at that too.
Thank you. Following up on brain activity, Is it common to see regressions? In this example, the daughter has been speaking phrases from 2.5 to 3.5 years old, and then there was a decline in speech from 3.5 to 4, and in the past few months has not been speaking at all.
So that's not commonly what we've seen. If someone were having uncontrolled seizures, they could have some regression at that point, but hopefully, and that's part of why we try and get seizures under control. But once children really achieve a milestone, in general, they're maintaining and continuing to grow. So that's not typical.
Okay, I have one more question, if that's all right. With the upcoming publication, do you think that will help develop a standard of care for our children? We often find challenges getting the appropriate therapy, such as behavioral therapy, without an autism diagnosis.
So that's the hope. I mean, so the publication that I think is being referred to is the natural history paper that Dr. Chung's team and the Simons team and our team put together, along with, so it contains clinical data, as well as brain MRI data and functional data from Dr. Verla's team as well, all together. So it's really a nice comprehensive study. It is, I want to make the team aware here, is that it's from the first 73 families where the Simons team had data. So it's not the total of 250 that are known today. So it's from 73 families. So that is the hope. It's a larger series than was previously published. So we really wanted to put that information out there so that it helps both doctors and families get more standardized care and everybody's aware of the complications. There's another resource that I want to draw your attention to that's also provided in the educational material, which is something called Gene Reviews. So we, Dr. Chung and I, co-authored a Gene Reviews article on Jordan syndrome. So if you just go online and Google Gene Reviews, it'll show up. You don't need a login, you don't need a password. And within that, you'll see just a search field in Gene Reviews where if you put Jordan syndrome or the name of the gene, it'll pull up what we know today about the best practices and standard of care for individuals with Jordan syndrome. This gets updated every few years as well. And that's a really good advantage because papers can be static, they're published one time and that's it, they don't get updated. But this actually gets updated every few years. I would encourage families, if they wanted to provide a resource to their doctors or other families, if they wanted another resource to provide, Gene Reviews is a good one as well.
And let's piggyback off of that, Carol.
Yeah, just
Can I just add the Gene Reviews is also available for the PPP2R1A. If there are families out there.
Yeah, thank you. So also in your binder is the care before the cure guide. And what we did as a team, we took that Gene Reviews and made it in very easy to follow, simple, ready to share program. It's right here. And the reference for the Gene Reviews link is also in there. So you can read through it. It'll talk about the therapies, the accommodations, interventions, everything we know so far. And again, we based it on the Gene Review that Dr. Mirza just mentioned. And we will be doing one for the 2R1A families as well. That Gene Reviews just launched recently.
It's just published this year. So.
Yep, so we will do a similar format for that as well. So just take a look at that.
And if you're sitting here now and wanting to see it, it's on our website in the Resource Center. So you can go to the Care Before the Cure guidebook. The Gene Reviews link is in there. It's all clickable. So if you want to see that, it's also available on your phones.
And it's printed. It's in your binder. So take a look.
And to add one last comment is that for the question about, autism without developmental delay or developmental delay with autism, Gene Reviews has actually done a lot of effort in the past few years to really give much more detailed guidance on developmental therapies. A lot of it is more towards the U.S. population, like developmental services within the U.S. system, but they are actively working on expanding and generalizing the information as much as possible to other countries about developmental services, exactly for this purpose. If a child has delays without autism, or if they have autism and they don't necessarily have other delays, how do you, go about that, and what kind of therapies do you need? So just kind of a practical tidbit, if you will.
All right, down in front, Sharon.
Hi. I have a question that follows on what Dr. Chung said earlier about over-metabolizing, like when we're eating. We've noticed with my son that we've had comments that he over-metabolizes medications for seizures. Like they've had to give him a lot more, but when they go test his blood, he's actually a lot lower than they think he should be. And so I didn't know if you've seen that with his population.
So we haven't looked at that directly. And I know metabolism is a generic word, but there are some ways that we metabolize medications and break down medications, and it's complicated because some medications you have to break down for them to work. So there's a whole area of medicine we call pharmacogenetics that has to do with that. We haven't looked directly at how 5D works in terms of those things. What I was referring to is more what we've seen as a research team in terms of things like amino acids or sugar or fatty acids and how those might be related. So we haven't looked at all at the question you just posed. We could be asking around, but we haven't looked yet.
So if you have the sequencing data, I might look into P450s. So P450s play an important role. There's a lot of individual heterogeneity for P450 enzymes. Maybe you can take a look at those or ask your daughter for the sequence. If they can send them to me, we can probably have a look at that as well.
Okay, next question. Where are we here? Ready over here, down front for Julie.
Hello, I'm Julie, and one note I just wanted to make before I ask my question is that I went to get Ollie's EEG and MRI scans to the Seattle Brain Research Team, and I was a little bit intimidated by it because I was worried I was going to have to spend more time on the phone with my doctor and all that type of thing, and it was actually like 2 or 3 emails, and it was very easy. So it wasn't, I had no phone calls, no time on the phone with the doctor. It was a couple of emails, and just they made it very, very easy. So just FYI about that.
Yeah.
The question I had was about seizures, and Ollie has very mild seizures in the sense that I think they would be very easy to miss. My question is if we've seen in the community any kind of kind of evolution of that to like mild seizures to more severe seizures as they age. I don't know if you have seen that at all among the folks in this community that do have seizures.
I haven't seen that progression. Have you?
In general, I'd say we're very data poor rather than being able to say that the answer is no. Number of people that have gotten, even 3 years worth of data has been minimal. In general, no, we haven't been seeing that. Again, I know you've heard me say this before. The period of time just based on other genetic disorders I'm most worried about is adolescence, when there are just a lot of hormonal changes and other changes. If we could get 100 people to the other side of adolescence and know there were no changes, then I could feel like I could say definitively no. But I would say I don't know. So amongst the group here, I would ask, I don't know, can we just ask themselves by show of hands, and you don't have to answer if you don't want to, but has anyone seen any significant progression where the seizures have gotten noticeably worse? Okay, so that's your answer, which is better than my answer.
And I'll just tag real quickly. So first, I want to give kudos to actually my team. Emily and Nora are our research coordinators who help with collecting brain MRI studies and everything. So just a shout out to them. I don't do any of the work. They do all the work. The other thing, I just want to make the families aware that brain MRI studies are relatively straightforward to collect. So just to let you guys know, again, if your child had a brain MRI scan you'd like to send to us, please talk to one of us. EEG studies, just to also make you aware, for full honesty, is that getting actually the raw data from EEG studies that are done at other centers, there are still some challenges with that. So it's not the easiest, which is part of why the Simons team is now doing EEG studies on site here. So we're working towards addressing a lot of the barriers with getting EEG data. There's a lot of issues with the type of EEG that's being done at different places and the type of the data itself. So just to make you aware, if we do run into challenges with that for your child, it really is something we're working on. So it might not be as straightforward or as smooth as the brain MRI data collection. So,
okay, over here now.
Conveniently related to that last one, so my question was, our son is 7.5, and for the first time about 4 weeks ago, he was hospitalized with repeated myoclonic seizures. So he's had myoclonic epilepsy, which was diagnosed when he was born. So we've always known about it. So I kind of had a few questions. I didn't know, his neurologist doesn't seem to really be settled on any advice. We don't know whether that he had these seizures because it was perhaps a hormonal thing, being around the age of 7, or whether it was a heat-related thing. And firstly, I wanted to know if you had any advice or thoughts on that. What causes seizures to get worse? Is there a hormonal spike at the age of 7 which could have contributed to it? Secondly, in terms of medication, the neurologist was reluctant to put him back onto anything because she basically said if hadn't really made much difference before, and therefore we just go back to the baseline. What's the importance of actually stopping seizures completely against sedation, if that makes sense? So he was put onto clobazam for about a week, which we felt actually helped him. It brought his baseline completely down, and we didn't notice him having any myoclonic seizures at all. Usually his baseline is he has maybe 100 a day or something, which I know sounds a lot, but for him they're very quick and he doesn't notice them and he isn't bothered. So we don't know whether it's better to just keep his baseline of him having those ones a day which don't seem to bother him, or whether it's more important to completely stop those seizures against him being slightly sedated, which we didn't feel bothered him again, but which the neurologist was more concerned about. Sorry, that was very waffly. I don't know whether my questions were clear.
No, I totally appreciate. To be honest with you, as we mentioned, again, we're not unfortunately your child's doctors, really. So it's really hard to give advice when we don't know your child. We haven't examined your child and things like that. In general, it's a hard choice between the risk of having multiple uncontrolled, especially if it's hundreds of episodes a day, versus the sedative effect of some of the drugs. Generally, what we advise is that we want to see actually which one will have a much more beneficial overall effect on the child, right? Because also, if a child is too out of it from the medication itself, that is not a good thing for their development either. It's a really tough balancing act, and it really comes down to, and sometimes it's a journey, where the doctors and the family might be on the same page at one point in time, and then they're not on the same page at another time in terms of which strategy to use. So we can't really give very specific advice here. I'd be happy to chat more one-on-one about, some of the considerations and things to think about. Hormonal changes do throw things off quite a bit, but it can be really stressful times during those periods of time. But yeah, other than that, I don't know, also, Wendy, if you had anything else to add to that. But
No, I was just going to say, though, that 7 years old is not usually when we see the hormonal changes, so I'd be looking for something else in terms of what was changing.
Yeah. And I think you had made the comment probably about contributing data. So I thank you for providing, that information, because again, it's really helpful. This is you're having more challenges with seizures. It's really important for us to know that information, actually, particularly this frequency that you're talking about. So thanks for, giving that information as well. Yeah.
Sandy, over to you. At what age are you seeing the hormonal seizures beginning?
So in general, what I would say, and it's not so much for this condition, but in general, is when we see hormones surge. So different individuals, it's changing. The age of puberty is actually going down a little bit internationally. So it used to be that I would think of it as 12, 13, 14, but we're starting to see some of those changes. And you can just look around sort of communities in terms of when girls and boys are starting to develop, but for some of them, they're developing as early as 9 or 10 even now. So, but that age can go, I would say, anywhere from about 9 to 15 as puberty's progressing.
Okay, let's see, who's, oh, go ahead, yes.
So this seems minor, but it's affected us quite a bit, and I was curious that it popped up on one of your lists. We seem to struggle with allergies, but it's a very funky display. She's not always sneezing as typical allergies, so it's not always very clear to us, but we finally had her tested, and she has really bad, or not really bad, but she had mold and then ragweed, I believe. And what was interesting, though, is, again, she doesn't sneeze, she doesn't look like a typical display. She just gets really uncomfortable and upset and does some stretching and looks like her muscles hurt. And I was curious because I saw that was grouped with asthma, respiratory allergies. Would you just say, is there anything you could offer in terms of thoughts around that? Because one of our challenges is trying to figure out the right time to medicate it, right? Because what happens is we don't, unfortunately, because she doesn't start sneezing, it's like a week of her being uncomfortable, and we're like, oh yeah, time to start the Claritin or Zyrtec.
Yeah, so we're not seeing any increased frequency of asthma or allergies in this community than I would say in the general population. What's a little bit differently is how the kids can communicate to us when they're having these issues or they're having the prodrome. And so I tend to be aggressive about just knowing if it's seasonal allergies and you know it's going to be ragweed or whatever, I actually look at the allergy index or the pollen index within your community, and then I try and start medications preemptively, because otherwise they're just uncomfortable, whether it's itchy eyes or runny nose or something. And if you can sort of dampen down the immune system before that starts, it's helpful. But talk to your allergist, immunologist, whoever you're seeing, about exactly what the right cocktail should be. But I don't think there's an underlying immune problem. I just think it's a communication problem and a sensitivity to sensory issues that they oftentimes don't appreciate or won't tell you. But that's really what's going on.
Okay, 15 more minutes. So back here in the corner, Kayla, I don't know if you can get over there.
Hi, oh, sorry. Brittany asked my question earlier, so thanks for doing that. So I just have a little bit more expanding on that. So my daughter is almost 5, and she kind of seen this big regression in speech. So we're just, and you kind of mentioned that it isn't common to see regressions, but we were seeing like lots of eye contact, super happy, super social, and then at the age of 4, regression and in speech, and now she's not speaking at all in the last 8 weeks. She did have pneumonia, but our doctors keep saying, oh, well, she must just be sick over the pneumonia, but we're kind of seeing like she's not looking at us the same. No, she's only had 1 seizure at the age of 1 day old. We haven't seen any. She's had a few EEGs, but we're kind of seeing behaviors of she's laying on the ground, she's pushing her head, she's chewing on things. She seems to be in distress, so we're just trying to figure out, like, is this part of the condition? Is this something else? Where do we go from here? Because we're from Canada, and a lot of our doctors are still virtual, so nobody's seeing her in person.
I mean, in general, what I'd say is you shouldn't be, from a neurological point of view, we're not commonly seeing regression as part of this, but I hear what you're saying, and it makes me worried that there's something else going on that just someone hasn't picked up on yet. And I don't know if it's undiagnosed seizures, that might be going on in sleep that you're not even seeing, but I would say number 1 is seeing her neurologist, and if she has an epileptologist from when she was little, just having them go back and make sure that the seizure is really clean, that there's nothing going on. And then from the other things you've seen, I know it's hard to do an in-person, but I would insist in terms of someone actually physically seeing her, if they need to run tests, whatever they need to do to see if there's something else that's undiagnosed that's medically going on inside her.
I wanted to just quickly tag on to that. I think it's, and we get this question a lot, is, in terms of like if there's a certain observation about regression or really bad epilepsy, for example, if we don't know that it's a core feature, it's important to check on the type of genetic testing that you guys might know all about this, but it's important to check on the type of genetic testing your child has had, which is why part of the Simon's screening, if you will, is to get that genetic test report, because there could be a situation where a child might have a mutation in PPP2R5D and another genetic thing going on that could cause seizures, or it could cause regression or something else. So there could be more than one thing going on. So it's really important also to kind of keep that in mind if you're noticing a particular problem, that you're facing, that it's not clearly within Jordan syndrome. It could be another thing going on as well, as Dr. Chung just mentioned.
Okay, I think there's one right over here. Was your question answered? Are you good?
I'm not sure if this is just a minor question, but is there a correlation between Jordan syndrome and overheating? We noticed with our 2-year-old daughter that the slightest increase of temperature, she's drenched in sweat. And she just started seizing herself, so I don't know if there's any correlation, if the rise in temperature could bring on the seizures.
So I'll say I do think there are issues related to what we call the autonomic nervous system. So I think there are differences probably in overheating, and we haven't gotten to the point of doing things like temperature monitoring and seeing what spikes during the day or things like that. But I do think there are things that are related to that. Sometimes I'll see the kids where they're, I don't know if any of you women have had problems with Raynaud's, but you go out in the wintertime and suddenly your fingers either blanch white or get really red. But I think there are issues that have to do with the autonomic system and blood flow sometimes that you can see either kind of splotchiness or the white or the red fingers, but other signs that there are things going on related to that. We haven't delved deeply in it, but I think your observation is not just coincidence, and I don't think it was just a hot day. I think in terms of, drenching in sweat, sleeping at night, being, like sheets, waking up in the morning and just wet and sort of wringing them out, it's not the first time I've heard this.
I just want to mention that's a common within our group. We had many families report that.
Yes.
I just wanted to add something on regression. I'm Pritesh. My daughter Juhi's 7. We didn't report any regression on any of the surveys, but when she gets sick, if it was a more severe illness, especially when she was younger, she would definitely experience regressions. I mean, there was a time where she couldn't sit up anymore where she was doing that, and it took months for that to improve. So we see it episodically, but certainly not now. But just wanted to share that.
Okay. Brittany, question from our virtual group.
How is Jordan syndrome related to Alzheimer's and cancer? Because of the PP2A's impaired function, how can it cause these diseases? Does it make the individual more prone to toxin buildup, inflammation, or other biochemical abnormality? And how can we prevent this from happening?
Yeah. So I think there's a lot of literature out there that refers to as PP2A like it's just one enzyme. But it's really a whole family. And the family itself, there is some relationships with cancer and Alzheimer's, but not necessarily the R5D. Yeah.
Okay, right down here.
Hello, my son is Alan. He has PPP2R5C, and recently he got diagnosed with what is called central Pococus puberty. So we noticed a lot of changes in his behaviors and a few physical change, and we couldn't figure it out. And then we saw the endocrinologist, and they did a lot of blood tests, and then they found out that the luteinizing hormone is high for him. So the doctor put him on the hormone injection every 3 months. So how often you see this issue, in the PPP kids? And then I'm just kind of curious, how it's going to change when he has his puberty, and it's just a lot of kind of question is in my mind, because this is kind of really new for my son. And also recently we noticed that he also has some kind of a episode, is like look like seizure. And so I don't know, because of the hormonal change now is kind of correlate with this, like seizure-like, episode. So he's going to have the EEG done again, because he has a past, and 2 EEGs seem to be like normal, but now with this, a lot of changes, we're going to have another EEG. So I just want to hear if anybody's in the community have similar issue with this, like central Pococus puberty. Thank you.
Anyone?
So for the PPP2R5C, we don't have enough information about a lot of patients. So we have about maximum 20 patients. The precocious puberty we have only seen in one. That's probably your child. I don't know how it is in R5D. I think there are a couple of cases. In terms of the seizures, it's very similar, I think, as for R5D. And from those 20 patients, we have seen it in about 50%. But it's a very small number to make general conclusions at this point. So we can compare with R5D, because I think it's very similar. But within the R5C community, the numbers are really too small to make any strong conclusions, I think.
Okay. We're going to take 2 more questions.
Everyone will have time this afternoon too, right?
Exactly.
To meet.
in small groups, so don't stress out if your question wasn't answered. Both Dr. Chung, Dr. Mirza, and Dr. Jensen's for our 2R1A 5C community will be available. You can schedule them through the Whova app. So I know there's a lot of questions.
Yes, please don't worry. There's plenty of time this afternoon. Jess, go ahead.
Hi. Through our course of getting to diagnosis, Sydney was diagnosed at one institution as having seizures all night long and was put on medication. Went to Mayo Clinic. They said it was not seizures. It was just an abnormal EEG. And here we are 7 years later, and we've never actually seen what we would call a seizure. But my question is, if you guys saw anything on her 6-minute EEG or whatever it was, would you let us know as a community if you saw anything unusual?
So if there was anything that was an overt seizure, we would, but the greatest likelihood is you're not going to get anything back in terms of that. But if there's something that we think is emergent that you know about, of course, we'll let you know.
Okay, let's take one last question. Please do keep in mind, we have all the opportunity this afternoon to do that as well. I think we have one more on this side over here.
Hello, everyone. My name is Janet. I'm from Australia. I know I am African. So my son is 16 months old. I know we are keeping a very close eye on the seizures, and maybe some children may have, I don't know if we're going to call them abnormal movements. So he, other than the lots of sweating, the other thing that he normally gets is spasms, where his body really tones up, like sort of like a dystonia kind of thing. And we've had discussions with his pediatricians, and I've taken videos, and he's actually had one. We had one when we were seeing the pediatrician, and they're like, no, that's not a seizure, And so there's not been very particular highlight of maybe these abnormal movements. And most so importantly is that they have been decreasing as he gets older. And if he's in your presence, if he's playing, he's with someone, you will never see them. But if you put him on the floor and by himself, he will get them. But any moment you just go over and just look in his eyes, it breaks off immediately. And when he gets that, he breaks into, he's also like the hot baby. And I have to be very, I'm very aware of the temperature. I'm African, so this is like super cold for my family. Wouldn't be in this room. This is like winter for them, and so I'm always aware. I'm like, okay, he's Australian, probably this is like normal for him. And even when I'm freezing, I'm like, okay, maybe I need to tone down the temperature. But the main thing is that movement. Are there those movements whereby it's not like seizure-like activity, but it's maybe just I guess associated with the Jordan syndrome because it's brain, neurons, and all that stuff.
Anyone like to speak to that?
I mean, just real quickly, yeah, absolutely. I mean, this is some of the challenges, is that sometimes you'll see what looks like seizure activity. It's hard to prove whether it is or it isn't. I would say in general, if he's had an EEG workup and things like that, I think you kind of factor all of those things into the picture because putting a child on an anti-seizure medication, if they don't have seizures, is also a challenging thing because you're dealing with a medication with side effects. There are some seizures that have a developmental window, so if they're decreasing in frequency after a while on their own especially, that's a great thing because that means they might be actually just occurring through a specific developmental window. Spasms are a very common type for that, where they might actually decrease over time, and they usually happen in younger kids. So these are just some of the general considerations, I would say. Yeah, absolutely. I mean, I think collectively what I'm gathering from a lot of the seizure questions is, again, there's a lot of it is happening. First of all, a lot of seizures are certainly occurring. Different types are happening, some more severe than others. Some are, being managed just conservatively and just watched. So I think all of that is really helpful to know about.